Good morning. This class we are going to discuss about some problems in differential equations, linear differential equations. Okay. Linear differential equations. If f of x, the right hand side of the equation, f of x is equal to e power ax into some g of x, some other function of x. The product of e power ax into some other function, that's g of x may be algebraic function or maybe trigonometric functions, sin x, sin squared x, cos x, something like that. So then how that particular integral will be taken. So here 1 by pi of d into e power ax into g of x. Okay. So our aim is to take this e power x from this product out. E power ax out from this product. So what we will do is e power ax we will take out. Instead of taking e power ax, we have to replace d by d plus a. We have to replace d by d plus a into g of x. Now the c of x is coming alone. Whether it is sin x or cos x or something x square or something like that, we can use the rule and solve it. So therefore, that exponential function will come out by using this technique, that is nothing but d is replaced by d plus a. Suppose here is e power minus x, that d is replaced by d minus a. That's all. So here is plus or minus, here is also plus or minus. So therefore this is the case. So problem number 1, solve d square plus 5d plus 4 into y is equal to e power minus sin minus x into sin 2x, e power minus x into sin 2x. Solution. So the auxiliary equation is m square plus 5m plus 4 is equal to 0. If we factorize this, m plus 1 into m plus 4 is equal to 0. So therefore m is equal to 1 or m is equal to minus 1 or m is equal to minus 4. So therefore the complementary function is equal to c1 into e power minus x plus c2 into e power minus 4x. Okay. c1 into e power minus x plus c2 into e power minus 4x, because the roots are real and distinct. So therefore the complementary function becomes c1 into e power minus x plus c2 into e power minus 4x. So then the particular integral is equal to, then the particular integral is equal to 1 by d square plus 5d plus 4 into e power minus x into sin 2x, e power minus x into sin 2x, e power minus x into sin 2x. So here our aim is to take this e power minus x out. So therefore e power minus x, then what we do is this replace d by d minus a. Therefore d divided by d minus a is equal to minus 1. d minus 1 the whole square plus 5 times of d minus 1 plus 4 into sin 2x into sin 2x. Okay. So therefore this is most important. This is the rule. The product of two functions e power minus x into sin 2x. So if that e power minus x will come out, it is very easy to solve because we know the rule. If sin 2x is coming alone, that d squared is replaced by minus alpha squared, that we know already. Okay. So therefore here that e power minus x will come out by replacing d by d minus 1. Okay. So therefore this is e power minus x into 1 by d square minus 2d plus 1 plus 5d minus 5 plus 4 into sin 2x into sin 2x. Therefore this is equal to e power minus x into 1 divided by 5 cancelled. So here therefore here t square plus 3d d square plus 3d into sin 2x. Now you use the rule of trigonometric function, therefore sin 2x. So here d squared is replaced by 1 by d squared is replaced by minus 4. So therefore minus 4 plus 3d into sin 2x into sin 2x. So therefore I can write e power minus x divided by 3d minus 4 into sin 2x. Okay. So therefore we have to multiply and divide by the conjugate. So therefore this is equal to e power minus x into, then only we will be getting d square here, we can replace it very easily. So therefore we have to multiply it by 3d by plus 4 divided by 3d plus 4 into 3d minus 4. 3d minus 4 into sin 2x. So therefore again I can write e power minus x into 3d plus 4 into sin 2x divided by 9d square minus 16. 9d square minus 16. This is equal to e power minus x into d is nothing but d by dx, the differentiation of sin 2x. So therefore 3 into 2 into cos 2x plus 4 times of sin 2x divided by this d square is also again replaced by minus 4. Therefore minus 4 into 9 minus 36 minus 16. So therefore I can write, so therefore here is 2, here is 2, so we will take out 2. So therefore e power minus x into 2 into 3 cos 2x plus 2 sin 2x divided by minus 52. So therefore this will becomes 20, this will become over 26. So therefore minus 1 by 26 into e power minus x into e power minus x into 3 cos 2x plus 2 sin 2x. This is the particular integral. Okay. So therefore the general solution is the general solution is y is equal to complementary function plus particular integral. So therefore complementary function is equal to c1 into e power minus x plus c2 into e power minus 4x. Okay, plus minus 1 into minus 4. So therefore plus particular integral is equal to minus 1 by 26 e power minus x into e power minus x into 3 cos 2x plus 2 sin 2x. So which is the required solution for the given differential equation. Okay, so therefore the next problem is problem number 2. Solve d square minus 2d plus 2. D square minus 2d plus 2 into y is equal to x squared e power x plus 5 plus e power minus 2x. X squared e power x plus 5 into e power minus 2x. Solution. So as usual, the auxiliary equation is m squared minus 2m plus 2 is equal to 0. M square minus 2m plus 2 is equal to 0. So therefore m is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. A is equal to 1, therefore 2 times of 1. So therefore again I can write 2 plus or minus square root of minus 4i. So therefore again 2i, therefore divided by 2. So therefore m is equal to plus 1 plus or minus I. 1 is equal to m is equal to 1 plus or minus I. So therefore the complementary function is equal to e power alpha x. Okay, because the roots are imaginary. The complementary function is equal to e power alpha x into a cos beta x plus b sin beta x. So this is the rule. So therefore complementary function is equal to e power alpha x. Therefore e power x into c1 cos x beta is equal to 1 plus c2 sin x. c1 cos x plus c2 sin x. So this is complementary function. So here particular integral we have to take we divide this into 3. Particular integral 1, particular integral 2, particular integral 3. Particular integral 1 is equal to x squared e power x. X squared e power x. Okay. So therefore I can write particular integral 1 is equal to 1 by d square minus 2d plus 2 into x squared into e power x. So the same rule we have to take out e power x. If we take e power x, definitely we must replace d by d plus 1 minus 2 times of d plus 1 plus 2 into x squared. So therefore this is equal to e power x into 1 divided by d square. I can write. Okay, so therefore this is equal to e power x into 1 by d square plus 2d plus 1, d square plus 2d plus 1 minus 2d minus 2 plus 2. 2 will be cancelled. So therefore 2d also will be cancelled into x square. So therefore I can write e power minus x into 1 plus d square into x square. 1 plus d square into x square. Therefore this is equal to e power x into 1 plus d squared the whole power minus 1 into x squared. This is equal to e power x into 1 plus x the whole power minus n minus 1 equal to 1 minus x plus x squared minus x cube plus etc. etc. So therefore 1 minus x, that is d squared, plus x squared, that is d power 4 minus etc. etc. into x squared. So therefore this is equal to e power x into 1 x square minus d square of x squared. D square of x squared is 2. 2 times differentiation. So therefore 2x squared minus 2. D power 4 of x squared is 0. Therefore all other terms becomes 0. Terms will be 0 into x squared. So therefore e power x into x. So therefore particular integral 1 is equal to e power x into x squared minus 2. Then particular integral 2 is equal to particular integral 2 is equal to 1 by t square minus 2d plus 2 into e of 5 into 5. If right hand side is 5, we will consider as into e power 0x. Into e power 0x. So therefore again by the rule d is replaced by 0. So therefore 1 by 2. D is 0, 1 by 2 into 5 into e power 0x. Therefore the answer is 5 by 2. So therefore particular integral is equal to 5 by 2. Particular integral 3 is equal to, again this is equal to 1 by d square minus 2d plus 2 into e power minus 2x. So this becomes what? 1 divided by d is replaced by minus 2. So therefore this is plus 4. So here is minus 2 into minus 2 again plus 4. Therefore plus 2 into e power minus 2x. So this is equal to, therefore this is equal to 1 by 10 into e power minus 2x. 1 by 10 into e power minus 2x. Therefore the general solution is, y is equal to complementary function plus particular integral 1 plus particular integral 2 plus particular integral 3. So therefore complementary function is equal to 1 plus or minus I, that is e power x into c1 cos x plus c2 sin x plus particular integral 1 is equal to e power x into x squared minus 2 plus particular integral 3 is equal particular integral 2 is equal to 5 by 2 plus particular integral 3 is equal to 1 by 10 into e power minus 2x. So therefore, which is our required solution for the given differential equation. Okay. One more important problem. The problem is solve d square plus 4. Solve d square plus 4 into y is equal to d square plus 4 into y is equal to x squared cos x. X squared cos 2x. X squared cos 2x. Solution. As usual, the auxiliary equation is m square plus 4 is equal to 0. M square plus 4 is equal to 0. So therefore m squared is equal to minus 4. So therefore this implies m is equal to plus or minus 2i. M is equal to plus or minus 2i. So therefore the complementary function is equal to e power alpha x, alpha is equal to 0, e power 0 is 0, then c1 cos 2x plus c2 sin 2x. c1 cos 2x plus c2 sin 2x. Particular integral is equal to 1 by d square plus 4 into x squared cos 2x. Suppose here is x squared, here is cos 2x. If cos 2x comes alone, we have the formula. X squared comes alone, we have the formula. So therefore I am going to convert this cos 2x in the form of exponential. So therefore e power I 2x is equal to cos 2x plus I sin 2x. The real part of e power I 2x is equal to cos 2x. Imaginary part of e power I 2x is equal to sin 2x. So therefore real part of e power I 2x equal to cos 2x. Now I am going to take this cos 2x, instead of this cos 2x, I am going to write real part of e power I 2x. So this is equal to real part of 1 by d square plus 4 into x squared into e power I 2x. Into e power I 2x. Instead of cos 2x, I am writing real part of e power I 2x. Now here is the product of e power I 2x. We will take out e power I 2x. Okay. So therefore this is equal to real part of e power I 2x will come out, and we will replace this d by d plus 2i, d by d plus 2i the whole square plus 4 into x squared only, into x squared only. Okay. So therefore I can write this is equal to real part of e power I 2x into 1 by d square plus 4id minus 4, because 2i squared is minus 4 plus 4 into x squared. So therefore I can write real part of e power I 2x into 1 by d squared plus 4id into x squared. Therefore again I can write real part of e power I 2x into 1 by, I will take out 4id, into 1 plus d by 4i, okay. So therefore into x squared. So therefore I can write real part of e power I 2x into e power 4i into, this is equal to 1 divided by 4id. Okay, so this is x squared. Good. So therefore 4id into 1 plus d divided by 4i into whole power minus 1 into x squared. Okay. So therefore this is equal to real part of e power I 2x e power I to x into okay, so then I can take 1 by 4I d into 1 plus x power minus 1 is equal to 1 minus x d divided by 4I plus d square by 16I square, therefore minus 16 okay into x square. So therefore I can write again this is equal to real part of e power I to x into I into I. Yeah, I into I, here is I square minus 1, so therefore here is minus 1 by 4 into 1 by d of 1 by d of this is equal to x square. So here we have to multiply by I divided by I. Therefore here is also I. Okay. So therefore 1 by d of x square minus 4I. X square minus 2x divided by 4I. 2x divided by 4I minus d squared is equal to 2, therefore 2 divided by 16, okay. So therefore 1 minus x plus x square I square is minus, good. So therefore I can write this is equal to real part of e power I to x, into minus I by 4 into 1 by d of x square. So this will become 2, so this becomes 8, okay. I can multiply this I also, so therefore this is equal to 1 by minus 4 multiplied by I, therefore I x square minus I cancelled, therefore x by 2, then I by 8, minus I by 8, here is minus I by 8, so therefore I can write minus 1 by 4 into real part of e power I to x into 1 by d, integration of this, d is d by dx, 1 by d is integration of this, therefore I into x cube by 3 minus x squared by 4 minus I into x by 8. So therefore I can write this is equal to minus 1 by 4 into real part of cos 2x plus I sin 2x into I into x cube by 3 minus x square by 4 minus I x by 8. So therefore here minus 1 by 4 into the real part, the cos 2x is multiplied with minus x by 4, therefore minus x squared by 4 into cos 2x, this is real part, okay, remaining or imaginary part. Then here I into I square, therefore minus 1 minus x cube by 3 sin 2x, then I into I square minus 1 So here is also minus, here is also plus, minus into minus plus. So therefore x by 8 sin 2x, x by 8 sin 2x. So therefore I can write this is equal to x squared cos 2x divided by 16, x squared cos 2x divided by 16 plus x cube sin 2x divided by 12, x cube sin 2x divided by 12 plus or minus x divided by 32 into sin 2x into sin 2x. So this is the complementary, particular integral. So therefore the general solution of this solution is y is equal to complementary function plus particular integral. So complementary function is equal to c1 cos 2x plus c2 sin 2x plus x cube sin x, x cube sin 2x by 12 plus x square cos 2x by 16 minus x sin 2x divided by 32. So therefore which is the required solution for the given differential equation. Thank you.